In this lesson, we're going to tie together everything that we've done with slope y-intercept form and standard form and intercepts, and just sort of bring that to a close so that we can wrap it all up, tie a bow on it, so to speak, and then we'll be ready to move on to our next thing. All right, so here's a little bit of a recap of some of the things that we've learned previously. An x-intercept is the point where a graph crosses the x-axis. So just in reference to the picture you can see on your screen or on my screen, the x-intercept here is at -4. It's on the x-axis. I put a green dot there just to represent it. The y-intercept is the point where a graph crosses the y-axis. And so the y-axis on the grid that you can see, I put a light blue dot at +3. That's my y-intercept. I can clearly read them if I've got the graph, right? And then it says circle both on the linear relation provided. Sure, here we go. Here's the y-intercept. Here's the x-intercept. How do we use intercepts to graph a linear relation? Well, imagine that the graph wasn't there, that all we had was that green dot and that blue dot. Then we could put a ruler down, we could draw a line between them, and that's in fact what we did last lesson, and we can very quickly have our linear graph. All right, so that's for recap. Now here's a few different types of questions that you're going to see. This first one was taken from the provincial math test. It's the kind of style you often see for multiple choice questions on the EQAO provincial math test. So let's just take a look at it. Salazar is asked to graph the linear relation represented by 2x minus 3y plus 6 equals 0. What's the y-intercept of this line? So we have to read these questions carefully. It's not asking us to graph it. We could put it in slope y-intercept form if we wanted to graph it. We could get the x and y-intercepts if we wanted to graph it. But all this is asking us for is the y-intercept, which I could get either way. Probably the easiest way, though, if all I want is the y-intercept, is to let x equal 0. Don't like using blue or red, though. I'm going to use blue. Let x equal 0, and therefore that x term just disappears, right? And so what I'm left with is -3y plus 6 equals 0. And then I solve it from there. Oops, I want to rearrange first, though. Being a bit hasty. So what I have is -3y equals -6. And then I prefer to do my division. And so I've got y equals +2. And so my answer is C. And so I showed my work, I got my answer, and I feel comfortable with that one. Graphing with intercepts. Okay, we've already done this before. I purposely put a couple of difficult questions with big numbers in there because it makes it easier. It gives us a chance to see when it's more useful to use x and y intercepts. For B part in particular, if I was to put that in slope y-intercept form, I'll just quickly write that out so you can see what it would be. It would be y equals -7/11 x plus 20/11. Who would want to graph that? Yes, that's in slope y-intercept form, but how would I find 20/11 as my y-intercept? Easily. And then from that, I have to use a slope of -7/11. That's not a nice thing to have to graph. So here's where getting the y-intercept and the x-intercept will be more helpful. So I know I've already got the y-intercept for that one, but let's just pretend I didn't. So to get the x-intercept, x-intercept, let's start with that. We're going to let y equal 0, and if we let y equal 0, then this term here disappears, and I'm left with 7x minus 20 equals 0, 7x equals 20, x equals 20 divided by 7. And of course, we already knew that from... Oh, we didn't already know that because that was the y-intercept I found. Never mind. Anyway, we'll get to the y-intercept in a second. This is the x-intercept I just found. All right, so there's my x-intercept. And if I want to get the y-intercept, I'm going to let x equal 0. And in that case, this term's going to go away, right? And I'm just left with 11y minus 20 equals 0. And 11y equals 20. And then I'll divide each side by 11. And this is the case where these two are the same, right? But let's pretend I didn't actually do it that way, that I just did it the one way. So here's my two things. Now I don't have to worry about slope. Even if it's an awkward graph like this, even with an awkward slope, it doesn't really matter. I can just go y equals 20 over 11. Again, probably useful to think about it like a decimal, so that would be, or at least a mixed fraction at the very least, 1 and 9/11, which is approximately equal to 1.9, right? So 1.9, I can put it about there. I don't need to be that precise. There's 1.9. And this is approximately equal to 2 and 6/7. So again, I can be pretty, I can be as accurate as I need to be for my x-intercept there. And I can still do a nice graph even if I don't have, without calculating the slope and all that extra trouble. So that's the first one. Well, that's actually the second one. We'll call that B because I didn't do them in the right order. To get the x-intercept for this one, we're going to let y equal 0. And then we're going to have, if I let y equal 0, I'm left with 5x plus 45 equals 0. And so 5x equals negative 45, x equals negative 9. And to get the y-intercept, I'm going to let x equal 0. And again, that x term disappears. I'm left with negative 3y plus 45 equals 0. Negative 3y equals negative 45. Divide each side by negative 3, and I get y equals positive 15. Okay, there's my x and y intercepts for that one. All right. Wow. Now, obviously, this is only going to work if I have a scale that I can use. This one, for the first part, I was assuming it was going up by ones. Let's actually backtrack here. Do I want to do that? Yeah, I'm going to backtrack. Sorry. It's my prerogative as a teacher to change my mind. Just for this one, I need to be able to get this 15 onto the scale, right? I need to make a scale that's going to let this 15 get onto it. So I've only got 6 blocks to work with here. So maybe I'll go up by 3s. So let's say, let's zoom in so I can write small, 3, 6, 9, 12, 15. That means I want all of them to go up probably by that amount. They don't have to. I only need to make the horizontal scale go up to negative 9, right? So maybe I'll go by 2s on that one, just to have a little variety and make the maximum use of my grid here. So I'm making my horizontal axis go up by 2s, I'm making my vertical axis go up by 3s. That way everything will fit for the first one. That means I have to regraph the second one, but that's not a big deal. All right, so negative 9, positive 15. Negative 9, positive 15. Connect the dots. And that's not too bad. There's A part. Let's go back and do B part. So this was my x-intercept here. This was my y-intercept here. Let's use a nice color for that one. So x was just under 3, right? So 3 would be halfway in between. I'm going to go just below that, so just shading towards the 2. And for 1 and 9/11, that's just under 2. That's going to be about 2/3 of the way up here. Again, I can't be that precise with the grid that I sort of had forced upon me, but I can do the best I can. And again, I'm just trying to hit all, or fill the whole grid. So there's my line there. And again, it's not that much work. Here's one more, just playing around with both standard form and slope y-intercept form. So a line is perpendicular to this line, y equals 2x plus 3. It has the same x-intercept as this standard form line. Then we have to find the equation of the line. So this is really bringing a lot of stuff together that we've learned over the past few weeks. So as far as the slope goes, that's what this part is telling us. I'm just going to draw an arrow here, and I'm going to say that the slope of this line, of course, is m equals 2. A perpendicular slope, remember I use that little symbol like that to show perpendicular. I think of it like a fraction. Think of 2 as if it's a fraction. Flip that fraction upside down and change the sign. So the slope of the line I want is -1/2. Then I have this one where I need to take the x-intercept from this one. All right, no problem. So if I want to get the x-intercept, I'll let y equal 0, and that makes the y term disappear, and I'm left with x plus 10 equals 0, x equals -10. So I've got the x-intercept, but what do I do with it, right? They're not asking me to graph it this time, they want the equation. So what I should do is think, okay, x-intercept is -10. I should actually think of this as a point. So the point is -10, 0. Right, so I got the -10 that I just calculated. I had let the y equal 0, so I got that. The reason why I want to think of it as a point is so that I can then use that to calculate my line. So this is going back a few lessons now. We're going back to y equals mx plus b, because that's what the question asked for, right? But I can substitute in my slope. Again, a lot of arrows going on, but hopefully they'll help a bit. Y equals -1/2 x plus b. I don't know what the y-intercept is of the one I want. All I know is that it goes through this point here. And if it goes through this point, I can use this as my x-coordinate, and this is my y-coordinate. And with some more arrows, x would go here, y would go here. And so now I've got 0 equals -1/2 times -10 plus b, and I can calculate b. So 0 equals positive. Negative times negative is positive. 1/2 times 10 is 5 plus b. Bring the 5 over to the other side. 0 minus 5 equals -5. There's my b value. And I can put this all together and say y equals -1/2 x minus 5. And this will be my final answer.